Good afternoon, everyone. Thanks for joining on Valentine's Day. Just to get a poll, in a sense, for the audience, how many of you folks are from IT, cybersecurity backgrounds? Okay. How about OT, automation? Okay, great. So today I'm going to talk to you about network anomaly detection, abusing ICS features, and hopefully as we go through the slide deck, you'll get a sense for what I mean by that. So just real quickly, I'll talk about a little bit about myself, about the company. We'll go over some acronyms, and I'll describe some common ICS incidents in the community and some lessons learned that we've taken back at Sempra and SoCalGas. And then finally, we'll go through the network anomaly detection project and tell you our journey, lessons learned, and where we are today. Oops, sorry about that. All right, so I've been in the energy sector about 5 years, 10 years in the information security space. Most of my focus has been on ICS SCADA security in the past 5 years, I would say. Started my career at ConocoPhillips on the IT side, and I was tasked with patching and hardening the SCADA servers. And when I was tasked with that, of course, the operations team first told me, "Oh, you don't know anything about OT. You really don't understand our environment," and said, "You know what? You're absolutely right. Let's take a step back and help me understand that." So after many lunches and many meetings with them, I helped to understand that better. Moved on to Chevron, and where I was doing cyber threat intelligence, focused on ICS SCADA security, so building out their incident response process and working with the OT folks. Brings me today where I am today at SoCalGas as a cybersecurity consulting lead. So our team does cybersecurity risk assessments for IT and OT. And part of the risk assessment is to identify any vulnerabilities and risks and minimize that to an acceptable level. One of the major projects that I was fortunate to work on was the network anomaly detection project. So we'll go through that today. A little bit about SoCalGas. So it is the largest gas distribution utility in the nation, with 21 million customers and 20,000 square miles. You hear a lot about regulations on the electrical and grid sector, but pipeline and the natural gas sector also has some regulations there. So we're subject to a couple of federal regulations and the California CPUC, of course. And so we're in the gas distribution, transmission, and storage spaces. And one thing I think is interesting to note is that, at least in California, 50% of power generation comes through natural gas. So if you think about it, it's sort of an indirect attack. You can impact the grid indirectly. So based on the poll, I'm not going to spend a lot of time here about telling you about ICS and SCADA. You all seem very smart in that regard. But I will mention briefly network anomaly detection. That's an internal acronym that we use at Sempra, and it's basically a methodology to detect unexpected deviations. So to do that, you really need to understand what is normal, work with the right folks who really understand the environment. And the goal, well, there's really two goals. One is to get visibility in the environment, and the other is to understand, ensure cyber resiliency. So how do we do that? Basically, as previous gentleman described, we use a technology that spans to switches at the OT sites, at the compressor sites, and we're passively gathering data and trying to understand the packets, and it's tuned for our ICS protocols. So we'll talk more about that later. Um, These are some common ICS incidents that have been observed throughout the world. I think many of them are well known, but I just want to make note of a few of them that you may or may not know. 2006 to 2012, there was some industrial IP theft, and it was targeted against US natural gas pipeline operators. And basically they were trying, it was basically industrial espionage, so they're trying to steal pipeline schematics and really get an understanding of how we're operating as natural gas provider in general. And then of course, 2010, you have Stuxnet. I don't think that needs much discussion there. I think everyone's familiar with that, but one of the things I did want to note is it spawned a few other malware threats, Dooku, Flame, and so adversaries learn from what's successful from others. 2013, we had the Havix malware, which was targeted towards the US-UK energy sector. Scanning, again, trying to gather data, possibly for a potential attack later on. 2014, this was again more industrial IP theft against the northeastern grid. And this was actually the same adversary that the DOJ indicted them, the same actor back in 2006, 2012 timeframe. And then of course, that brings us to Ukraine. There was 225,000 customers without power. And not only did they make power, or turn off the power, so to speak, they made the restoration very difficult, overriding serial to Ethernet devices and telephone denial of service as well, among other things. 2016, we had Ukraine again, and this time it was a little bit different because they leveraged ICS-specific protocols, so IEC, if you're familiar with that. And 2017 came around. We thought there might be a third Ukraine, right? But there wasn't. Instead, we had a number of ransomware intrusions spreading throughout the environment. WannaCry, Petya, not Petya, and these were not ICS-specific threats. But if you did not have proper segmentation, that could spread to your ICS environment. So let's talk about Ukraine specifically and some techniques and procedures that we observed because we as a company wanted to understand how can we defend against that. There's a lot of boardroom discussions as there were, I'm sure, in many other utility companies. So one of the common TTPs is spear phishing. That's on the corporate level, gathering credentials, sending you an email, clicking. So to help with that, we have a phishing a campaign where they send emails to all of our users and try to understand who might click, and that helps. And then we have credential theft. So that might occur on corporate environment or it might occur on the ICS environment. You had VPN remote access. So Ukraine 2015, they leveraged legitimate credentials, access to VPN, and so taking that back to our environment, we wanted to consider VPN capabilities and really understand how those are being leveraged. Abuse of ICS features and operational knowledge, and I think this one was key. If you've noticed, as we've evolved, I think the threat actors have really started to understand you do not need to have a fancy 0-day, at least in the ICS environment. You can simply have some operational knowledge, and I understand that's unique to every ICS environment, and you have different protocols. But once you start to understand that sort of thing, you can leverage existing features. They also targeted very specific systems, so we wanted to keep a close eye on those type of assets. So human-machine interfaces, OPC assets, serial to Ethernet devices. And as far as the project itself, our other utility, San Diego Gas and Electric, also had already engaged in this technology, and they've already began the journey. And some of the benefits that we could see were visibility in the ICS environment. So that alone has multiple benefits. Asset identification, so really understanding what you have and perhaps what vulnerabilities they might have, and in general, it has other value besides cybersecurity. So from our perspective, we had two primary objectives. It was to detect potential threats, misconfigurations that could impact cyber resilience. Misconfigurations are not really a threat, but they could have the same adverse impact. We also wanted to triage high fidelity events to the Security Operations Center. So like many organizations, Security Operations Centers don't have a good understanding of OT, and we really need to help them to have the proper steps. What steps should they take to triage those types of events? So again, just to reinforce the idea of being successful for network anomaly detection, you really need to understand the baseline, what's normal behavior. So these are some use cases that we came up with. The first on the threat detection side is abusing features for nefarious purposes. So I think many are aware that there are certain features that you can leverage that could be used for good or bad. So for example, we're a natural gas pipeline company, and if I tell you we're opening and closing a valve, is that good or bad? Who knows? We really need to understand the context. And so, but at least knowing that that command happened. Also, identifying any host that may have connected on the network. We talked a lot about industrial espionage. We have some of these devices that sit in DMZs where you have engineering workstations and you may have sensitive drawings there. Misuse of corporate accounts. So we have some assets that sit in the DMZ and they're used to access data, or the corporate users access data, and they should only be accessing those assets and not to other field devices. So we want to make sure that those accounts and those assets are well segmented and monitored. From an operational perspective, misconfiguration, we talked a little bit about that. Bandwidth consumption. So often our OT folks have limited bandwidth in some of these remote sites. They may have satellite links or other low bandwidth communication, and they want to understand what endpoint is using all the bandwidth. So this technology helps us understand that. And asset management, so understanding what we have, what models, the firmware version, and so forth. Going further into the requirements, we wanted to understand the layer 7, the application layer we are running, what sort of commands are run, and then that can help along with other information, such as firewall logs and logs from other sources, so we can enrich that data and take action on that. We wanted to passively detect. I think that's a key word there. Many operations teams don't want a active tool or something to block things and block operations. So we wanted to make sure that the tool had no capability to cause any disruption to operations. Provide visibility to both IT and OT. There aren't a lot of tools out there that can provide visibility at the packet level. And talked a lot about the misconfigurations. As far as the communication flow, I think it was important for us to know which assets are talking to who. If you have system A talking to system B. That's useful, but it's even more useful if you know the conversation, what commands are being run, similar to the first point. So this is a high-level overview of our journey. At the top there, you'll see some of our remote compressor sites, so you can get a feel for how remote they are. And Q3 2016, we started our first pilot in a remote desert site. Of course, you had the usual, the rightful concerns of, is this tool going to use any bandwidth? We have slow latency. And we've proved that that wasn't the case. And how valuable this tool will be. And we've gotten to the point where some of our operations teams are really starting to dive into the tool and see some operational value. Q4 2016, we had the Ukraine intrusion, and I think that helped supported our case that these threats aren't going away, and they're evolving, they're growing as far as operational knowledge. And then we went on to make a case for deploying it to all compressor sites. So we have 13 compressor sites, 2 control centers, and those 20,000 square miles. By the third quarter, we're good to go, we're approved. And next quarter, immediately we see some quick wins, I would say. For example, we saw 50 stranded assets, and what I mean by stranded is they were re-IP'd at one point, and they weren't managed. So we had to go back and take note of those so we could update the IP addresses. So I'll talk more about that in a few minutes. We really understood the ICS network and how they were communicating among each other, especially at the application layer. So for example, our applications started to emulate SMB connections, and this is at the time of all these ransomware attacks. And we're like, that's suspicious, and then starts to emulate who has access to those SMB shares, and that's also suspicious. So start going down this path, and for most cybersecurity people, this seems like traditional reconnaissance. Long story short, we work with the automation vendor and our OT folks and learned that this is actually normal behavior for the application. So we really got to know the application at that layer. And then Q4, again, we had another incident, which was the safety system. So that's the Trisis Schneider Electric system, safety system. And again, I think that helped reinforce the idea that ICS threats are still continuing to evolve, and other adversaries are learning. So briefly, I'll just touch on some of the lessons learned from the technology. As far as the stranded assets, we identified engineering workstations, managed switches, PLCs, printers, serial to Ethernet devices. And I made a note of the red ones because those were commonly targeted in recent years in Ukraine. And we identified a new ICS protocol. So at the very beginning of this project, we thought there was a certain number of protocols we expected to have, but in reality, there is another protocol that we're actually using. So we learned more about our architecture and our protocols. And it improved our understanding of the ICS environment. How is the communication between the two compressor stations, or multiple compressor stations? So in summary, I think if you are considering something like this, you need a people process technology. This is not one of the solutions that you can just set and forget it. You need people that really understand the environment and can analyze and triage those events, take action on them. And you need a technology that will meet your requirements. So I briefly touched on some high-level requirements for our project, but you may have different requirements. And finally, you still need the security basics. You still need network segmentation and architecture. There's well-known guidance on that, from ISA, and so you still need that. You still need log management, someone to not only gathering logs, but actively reviewing logs. A secure remote access, so really understanding who's remotely accessing your environment and having some way to secure that. So for example, one of the things that we do is we have two-factor authentication. We hold the token that's dynamically generated. So when the automation vendor wants to remote in, they have credentials, but they still need the token. So we can still have some control and understand when vendors are accessing our environment. Access control, not using default credentials. And finally, security assessment, really understanding what assets you have, what vulnerabilities they have, and how you can mitigate against those vulnerabilities. And thank you.